Hello, this is topic 9. Topic 9 about the skin. And this is the first organ in this semester. And the skin is, in human, the skin is the integumentary system is the skin. And in human, in all of those vertebrates is the skin. And then in insects, it's the exoskeleton. And first, let's in this class we just focus on in the focus on the human skin. In human skin, I think we just learn in the lab, the human skin can be divided into yeah, this one. So, yes. Okay. So the human skin have mainly three layers. Let's see. Yes. Epidermis, dermis, and dermis, and hypodermis. And hypodermis, in many cases, we don't call it hypodermis, we call it subcutaneous tissue. And let's first focus on the epidermis. Epidermis is mainly, there's mainly one type of cells, keratinocytes. Keratinocytes is 95, I don't know the number, but so at the very baseline of the epidermis, there's a basal layer. And in this basal layer, not all the cells, but some of those cells are stem cells. And these stem cells keep dividing to make more keratinocytes on top. And then when the stem cells meet new cells, the old cells pushing forward to migrate to the surface of the skin. And when they migrate, also changing. At the beginning, this called spinous layer. In the spinous layer, these keratinocytes are linked together with a cell-to-cell junction called desmosome. Desmosome is a kind of an anchor between cell to cell. They are strong to endure. They endure strong physical impact. And then first migrate up. These cells begin to carry granules. So this is called a granular layer. And this granule in the keratinocytes contain lipids, mainly contain lipids. And those lipids will be further secreted on the top of the cells, which will have later, they serve as a sealant. And also, in addition to the lipid, they also produce the antibiotic, the peptides that protect the cells, that protect the skin. And then when they further migrate, the lysosomes in the keratinocytes dissolved, and then they kill the cell itself. And then when they died in the cells, it mainly contain keratin. And this keratin containing that the keratinocytes called a keratinized cell. And the keratinized cells, they are on the very top layer, corneum layer of the epithelium. And these cells very strong because they contain keratin, and also between the cells they seal with the lipids that secreted by the granular cells. And this together, this mixture, they are waterproof. They serve as a very top layer of the skin to prevent any water soluble things from getting into the body. And this lipid sealant and the keratinized cells, plus in the granular layer, all the cells also connected together by another cell-to-cell junction called a tight junction. Tight junction, by the name, you can tell that it's very tight. This tight junction is so tight it prevent even water molecule from getting through. So all of those three, the lipids, the keratinized cells, and the tight junction between the granular cells, all of those make something we call permeability. mobility barrier. And this is almost, so this is about the epidermis. And beneath the epidermis, there's a dermis, and dermis itself can be divided into two layers. And some like in the dermis, and between dermis and epidermis, this is not a flat layer. It's kind of a wave. This wave, there's the nipple-like structure of the dermis called papilla, or papillae if it's a plural form. And then in first layer, this layer is more dense. This is called papillary dermis. There's a papillary dermis, and down reticular dermis. And this is papillae, and this is called dermal papillae. And this dermal papillae has can be specialized in multiple structures. One structure in human, two of those papillae join together. And this is forming the fingerprints in our hands, in our feet. And then whenever we have a fingerprints, there's a lot of not only the fingerprints, and here's a lot of sweat gland, and then also there's no hairs growing. And then in some of those other animals like sharks, like some snakes, turtles, this papillae form into special shape. This is the scale. And then in mammals, and of course mammals do not have scale, the epidermis and dermis going down to form a hole, and then in the bottom of the hole there's a papillae, dermal papillae, and this is a hair. It's a hair follicle, and from the hair follicle we grow the hair out, and this hair, this is a mammal hair and human hair, and hair is a special structure only in mammals. And how the hairs grow, please keep in mind the hair, it sounds like they grow from the papilla, but it's not. It does not grow the papilla, but rather here. This is called a bulge. A bulge is somewhere between almost every hair has a muscle called erector pili muscle. And when this muscle contracts, it makes the hair stand up. And then all of those hair has this sebaceous gland to produce the oil to moisturize hair and the skin. And somewhere in the muscle attaching and sebaceous gland, you can find this bulging stem cells. The bulge stem cells contribute to make cells incorporate into the hair to grow the hair. And also, they can also make all the cells, including even this sebaceous gland cells and everything. This is called sheaths. The sheaths of the root sheaths of the hair is also made of the cell, then is produced by the bulge stem cells. And then, what is really the hair? The hair actually made also keratinocytes. It's not only keratinocytes, but also the keratinized keratinocytes, which means that dead cells. And then, hair also have colors. Where the color came from? At the bottom of those, they call it melanocytes. The melanocytes is located right atop the dermal papilla, and melanocytes produce melanin, and melanin is incorporated to the keratinocytes, and through the melanin, and then this gives not only the color of the hair but also color of the skin. I think I forgot to mention that melanin is located on the basal layer of the epidermal, and then for the same way, melanocytes is some cells like has a lot of a tentacle out there, a tentacle here, and then each of the tentacle they call it dendrites. We call it arm or tentacle. And the dendrites, and they produce melanin inside the melanocytes. The melanin is incorporated into a organelle. This organelle called melanosome, and they deliver the melanosome into into a keratinocyte, and then the keratinocytes have a color. So human and we human have different skin color and different hair color. How the skin color and the hair color determine? It's not because the number of melanocytes. No, it's not the number of melanocytes, but it's because how many melanin that each melanocyte can produce. And there's a process called melanogenesis. And for people with light color skin, they have produced less melanin. And for people with a darker skin, they produce more melanin. And then, people, when people grow older, their hair become gray, and why the hair become gray? That is not because they have less melanocytes, but the melanocytes become less function and produce less melanin. And this is the melanin. What else? What else? Melanin and hair. What about hair? I think that's all about hair. And after hair, let me see. Oh yes, and then in mammal, hair. In birds, it's feather. And in a reptile, is scale. Reptile scale, not fish scale. Not fish scale. No. Fish scale. No, not all of those have the same origin, called evolution homologous structure, evolutionary homologous structures. So all of those came from the papillary dermis. Yeah, I think that's it. That's about the papillary dermis. And let's talk about the sweat. Larger sweat. Next we have the sweat gland. The sweat gland itself actually evolved from that. You have the epidermis. Still epidermis. Oh, interesting. Epidermis getting in. It is infold into the dermis, and then when it get in, become longer and longer. Eventually, they form a convoluted a tubule inside the dermis, and this is become a gland. Even the gland seems like a ball, but actually it's more like a tube forming a ball. And then inside, see, inside the ball is still kind of the tubes. And then how does the sweat gland produce the sweat? I mentioned in the class, I think twice. So basically, in our body, we do not really have a water pump. And how we, sweat. What is sweat? Sweat contains water. Not only water. If it tastes the sweat, is salty. So because sweat is water plus sodium chloride, water plus salt. And then how the body generates? The body first actively pump sodium chloride or salt into the sweat gland, and then it generates. This place is a hypertonic environment in the gland, and as we mentioned, water migrates from the hypotonic side to the hypertonic side. When the body generates a hypertonic side in the gland, the water also come in, driven by osmosis. So that's how the body uses osmosis to produce the sweat. The major function of sweating is to reduce the body temperature, and amazingly, our human have temperature. The human has a very high density of sweat gland, and then we generate a lot of sweat to reduce our body temperature, which make us the champion of long distance runner. And there's other function of the sweating. One important function of the sweating is the accelerate lactate. Lactate is a useful useful material. Normally, it generated through the anaerobic glycolysis of glucose. When we are just resting, we generate not too much of a lactate. Most of those go to the liver and become glucose. And be used by other organs such as a muscle. However, when do we generate a lot of lactate? When we are actively exercise or having physical activation, and then too much lactate, it cannot accumulate in the blood. How we can get rid of the lactate? Through sweating. So sweating is an important way to get rid of the excess lactate when we are actively exercising or have intense physical activity. I'm still writing. This is so ugly. So that's a sweating. What else? After sweating, yes, and also in our body, there's two types. This sweating, we call it eccrine sweating. They also have a apocrine sweating. Apocrine sweating in a human is only in a small in special places, like for example in a wing of the nose, nostril wing, and in the armpits, and their function is generate a human odor. In human is less, and actually in fact this is produce oily substances. And this oily substances actually itself does not have a strong odor. The real strong odor is metabolized by the bacteria that live in our body. And so in human, it's not that greatly important in the regular apocrine sweating, but in some other animals, for most other animals, other than primates like monkey or apes, the apocrine sweat is more popular or they have more apocrine sweating than the eccrine sweating. That's because they use a lot of the thing to communicate. They try to attract the sexual mating pair. They try to warn others, I'm here, don't come across. But also in mammals, the apocrine has a very special function, because in mammals we have milk. The milk is made by mammary gland, and the mammary gland itself is a specialized apocrine sweating gland. So that's another special use of apocrine. And then lastly, let's talk about the fat. In the subcutaneous space, the majority of those things is made of fat tissue or adipose tissue. And those cells we call it adipocytes. Adipocytes, in most adult human beings, the adipocytes is, we call it white adipocytes. A white adipocyte has okay, it's good. White adipocytes. A white adipocyte, like this is cells, but majority of cells is occupied by a big, we call lipid droplets. And the lipid droplet, this contain lipid droplets. It contains a lot of lipids, and this is the major function of those is store lipids. And this the adipocytes in adults, human, but when we are young, we have another cell called brown adipocytes. A brown adipocytes also contain lipid droplets, but it's a nucleus. It has multiple small lipid droplets, and in addition, it has a lot of high contents of mitochondria, and this mitochondria gives it a brown color. Mitochondria has color, and this brown adipocytes, this function is not store lipids, but rather use lipids. It use lipids, it burn lipids to generate heat. That's how we maintain our body temperature when we were young. We generate heat from the brown adipose tissue. But when we grow older and older, this brown adipose tissue becomes less and less. And nowadays, many scientists now are doing research how to convert the white adipocytes into brown adipocytes. Some of the research indicating that a low temperature will convert the white adipocytes into the brown adipocyte. This is called browning. Yeah. Okay. I think I forgot one thing. Lastly, let's talk about a cell called fibroblast. Fibroblast logically is in our body. Fibroblast, when we talk all about this, in the dermis, the primarily is occupied by fibroblast. And what's the function of fibroblast is to filling the space. And how does fibroblast filling the space? Not only by cell, but also produce collagen. So fibroblast is the most abundant cell in the human body, not only in the skin, but also in the human body. And it produces collagen, and the collagen is most abundant protein in the human body. And so their function is to fill and make the shape here and there in many different places in our body. And also, other than filling the space, it's also doing for wound healing. Whenever we have a wound, the fibroblasts will come. And whenever we have a wound, first to heal the wound, you need have some blood clotting here. And then when you form the blood clotting, there's fibrin there. Some cells need to break the fibrin, and fibroblasts will break the clotting. And then after break clotting, it deposit the collagen in the site, in the wound site, and then it tells the immune cell, now it's done, you can go away. Immune cells, if the immune cells here, there's no way you can heal the wound. It tells the immune cell to go away, and then it recruit the blood vessels called angiogenesis to make blood vessels. So fibroblast is critical for wound healing, but when it does not grow well, what happens is called fibrosis. Fibrosis is that somehow only fibroblasts come, no angiogenesis. And the fibroblast is not very active either. There's so many not many fibroblasts, but they produce a lot of collagen. And then you have more collagen than cells, and this place will become hard and thick and not functional. It's high collagen tissue. It become a scar tissue. Maybe you have a scar on your skin, you can feel it's very hard. I have this one. But it's no longer functional. But this scar tissue is happening in the skin. It's okay. It's just maybe itchy, only doesn't look good, but it's okay. But if it happens in the liver, in the lung, in the heart, it's very serious disease if it happens inside the body. So fibroblast is also involved in the fibrosis. And also another thing is aging skin. When people showing wrinkles, it mainly because the fibroblasts is no longer functional and they do not generate enough collagen. So aging of the skin is not enough collagen, and the scar tissue is too much collagen, but for other reasons, not really fibroblasts to the cell to be blamed for something that's very complicated. And I think that's it. That's all for the skin. See you next time.